I'm Mark Mathis from Impact Observatory. So if you've heard of us, you probably heard of the land cover map. Started in 2020. I guess 2021 released the first global land cover map of the world at 10-meter resolution, and then went on to create a whole time series from 2017 up to present. When Impact Observatory was started, our goal was to apply artificial intelligence to geospatial problems, and started with training a convolutional neural network on some billions of pixels of training data to create a model and then apply that model at scale, and then again repeating that over time and getting to where now we can do anytime, any place, and showing here the talk today is integrating that with a language model to start to expose a natural language interface. And so this is prototype, but it is something that we use internally all the time, actually, which I can say in natural language, give me a 14 class map of this location in this period of time, and we'll actually submit that order to our backend processing pipeline, and then be able to show the result there at the end. All right, so with the computer vision model, it's a very well established technique, UNet architecture with CNN. We take the time to train the model because we have access to the training data. But it's not the case with LLMs. I think as the previous speaker mentioned, we're just using off-the-shelf models or commercial models, and we're leaving that training step up to the big tech companies to do that. And so how do we then take advantage of this new technology in order to do things that we actually want and avoid, take the good parts and leave the bad parts. So we don't want the model to make things up. The off-the-shelf models know some things about geospatial, but not very good detail. And if you want any kind of real answer, it's not a good choice. So there's a few common techniques. The first one is just prompt engineering. This is just giving your agent a story to start with, and then as you have a conversation with the model, you're just adding on to this story to give it more context in order to generate an answer, try and tell you what it thinks you want to hear. And you can get pretty far with these. So a lot of people are going to be very protective of their prompts. And a lot of that is trying to build up this context. Next would be the RAG approach, we also heard about in the previous talk. So I'm not going to go into that very much here. Would just point out, if you have like a corporate website, documentation, anything that you can just kind of roll through, anything that wouldn't have been available to the model when it was trained, you can kind of add that on after the fact, and essentially extending the multi-dimensional space that the model can search in order to generate a response. And so the last bit, which is really what I'm going to focus on for the rest of the talk, is tools or function calling. And I think it was hinted at in the previous talk as well, that the LLM is very good at writing the code, and it's much better at writing code of how to get an answer than giving you the actual answer that you're looking for. So I saw an example yesterday with actually a bunch of different currently available models trying to count the number of R's in strawberry. And most of them say 2. There's maybe one that would say 3, but it seems funny, and it is funny. But I think it helps to highlight kind of the boundaries of what you can do with these models. And so if you want the number of R's in strawberry, just a kind of silly example, you're much better off saying, can you write me some code to count the number of R's in strawberry? And then you run the code and get the exact precise answer that you're looking for. And, oh, there we go. All right. So why am I talking about this here? So in particular, open standards, I think, are super important for any kind of integration, but especially when we're talking about how can we take advantage of this model and capability that's being put out there by large tech companies. And a lot of that is leveraging open standards. And so we'll talk a little bit about Stack and then more about the OGC API processes spec. All right, so I'll get into it with some code. So for the first example, using LangChain, which is a kind of abstraction layer on top of the lower level models, which you can use to interact with different local models as well as the APIs. And so here is just the starting of a simple tool to interact with Stack catalog. And the way you do this is to create a Pydantic model for the tool and then define the inputs. And this description here is going to get lumped together with the prompt that gets sent to the model along with your chat history, the conversation. And so it enables the model to then say, hey, you asked me a question about finding imagery in a Stack catalog. I don't know how to do that, but I have a tool that would allow me to do that. And so it can correctly formulate inputs to this tool. And then we actually execute, in this case, an API call in order to get back something that's more likely to be useful than if it didn't have the tool. So likewise, Pydantic model for the inputs. Here you're looking at a description of like the date time for Stack catalog. You're providing this to a model, and then that gives it the ability to formulate a correct date time input if you said, show me images from the last week, or my favorite term, showed me images for the second quadrimester of 2023. It actually knows what that is, though you probably don't. All right. So that allows me to do something like this. Show me the 4 most recent Sentinel-2 scenes, formulates the input to that Stack tool, sends the request to, in this case, Planetary Computer, get back the link, and then just straightforward processing to create a layer that I can look at. All right. When I submitted this talk, I was going to present a toolkit, which is just a series of tools. And what I talked about before is technically a tool, because I'm just giving all of the collections directly to the search tool. And so what I can't do with that singular tool is say, hey, what's a good satellite for visual data? What's something that has a SWIR band, things like that. What kind of satellite should I use to accomplish some goal? And you could do that with a toolkit where we'd have a separate input that says, where you actually search the collections, you get back all of the descriptions, and then add that on to your prompt conversation history. And that works, but at the current time, it gets a little expensive and a little slow because you start carrying around more and more information with every request that you're sending to the model, which slows it down, and I suspect that'll get better over time, but for now we can bypass it and just say, here's the list of collections and move on. So I was going to talk about WPS and creating a toolkit in the same method where, and I still think this is a good idea. In particular, if you have some WPS processes, it'd be a very straightforward process to say, create that Pydantic model for the inputs, provide that list of processes to the tool, and then be able to access your WPS processes with the language model. But what I want to focus on is the OGC API, and the reason for that is, this example, just using PyGeo API running locally with the example Shapely tool that it has as an example. And with very minimal adaptation, and this is dropping the LangChain bit and looking at OpenAI's function calling API directly. If I take the list of processes and just reformat it to this tool description, just taking the ID description and the inputs, passing that into this tool description, which now looks something like this. So this Shapely functions, I'll read all this. And then tacking that on to the conversation. And so here, I'm just doing a very simple, how do I determine if one geometry lies within another? And the response now comes back because it knows it has this function called Shapely functions. It has a within predicate, and now it has enough context to say, I don't know, but you can call this function. And then it can help you formulate the request to actually do this. And so it says, provide two geometries. So great, use these geometries. And then now it can formulate that function call, which is shown here. And at this point, it hasn't actually done anything. So it actually hasn't written any code. It's much simpler. It just said, you want to call a function with this, with these parameters. And then it's on us to take that response now, go through it, and actually execute the call, which in this case is just calling the OGC processes. And comes back with a response saying, yes, that point is inside the other. And I think that's the end of my talk. So happy to take questions. Yeah.
In that last example where it ran within, language model to do that, like the PyGeo API.
Correct.
Okay, I'm just loading it.
And so that's the kind of the point I'm trying to make, is that we're moving all of the meaningful compute capability outside of the model to systems that we create and control. And the kind of standard geospatial operations can be useful in this context. This is also what we use for our kind of commercial day-to-day specific processing. So our own tools are available through the same kind of API. And so now it's just another example of I want to add new functionality to my chat agent. I just add another process to my service. Yeah.
Maybe still limitations on the number of tools that you can present to the LLM and how I use them.
Not really. So we, excuse me, we have 10 to 20 tools currently in the system that we run. And I think it does fine with that. There are some efforts. So I think it's probably a race. So I think the models will get better about using tools. And I think tens of tools, I think, shouldn't be a problem. There is some interest in, LangChain has LangGraph, which allows you to kind of group tools into different agents and then have the agents work together. I think that approach is kind of not ready for prime time just yet. So I think you'll probably see individual agents be able to handle more and more tools. At the same time, the kind of multi-agent approaches will probably improve as well. This simple example is obviously synchronous. For our processing jobs, they're asynchronous. And so we do have, well, there's two things. So one is to submit the process, which may take minutes to hours to complete, depending on what actually needs to be done. There are a set of tools within that to order, but then also check on things. So I can say, if you make an asynchronous request, you get back, yeah, I started it. And then you can kind of poll to say, hey, can you check on my last order? And even that context it does pretty well with. So you could say, my last order, you don't have to say, a specific ID or whatever. And then we have done some work with kind of an asynchronous notification. So if you have a chat and you've started an asynchronous process that completes, and then you get a non-user initiated response from the chat bot. So it gets notified independently and then just pops up and says, hey, your order completed. Now what do you want to do? Per the ODC API spec?
Yeah.
We don't. I'm not sure if that is part of the spec. I don't think so. But I guess you could extend the specification for your own purposes. But all right. Thank you. I'll be around.